All right, the binomial distribution of probabilities. We've looked at this before. If you remember at all, I'm going to add a page in here. Binomial distribution. Let's just say you were trying to shoot a target or shoot baskets, and you had a 70% chance of making the basket, and that means you'd have a 30% chance of missing. So a make and a miss. And let's say you shot 5 free throws so you're going to make 70% of your free throws. That would be a probability of 0.7 plus 0.3 to the 5th power. Okay? And then from there we had to calculate, all right, what's the probability that I'm going to make 3 of the 5? Because there's different ways to make 3 of the 5. So I would have to take 5 items 3 at a time in a combination. Remember, that was 5 factorial over 3 factorial 2 factorial times 0.7 to the 3rd power times 0.3 to the 2nd power. I'm making 3 free throws, missing 2 free throws. And I would multiply all that out. Okay, so that's finding one of the probabilities. Well, what we want to do is find all of them. And we don't want to have to do it all out, but we know it has to add up to be 1. So looking at a probability distribution in binomial situations takes a lot more time, because you'd have to do this for all of them, not just 5 things made 3 at a time. You'd have to do it for 5 made 4 at a time, 5 made 5 at a time, 5 made 2 at a time, and 5 made 1 at a time, and 5 made none at a time. Oops, not a fraction. Right, so you'd have to do that with all of these and expand it all out and multiply them all out. That's the probability distribution. Well, we're going to be doing it a little bit differently. Again, we still have independent trials. Those are the free throws we shot. We call it a binomial experiment because it's either a make or a miss. Probability of a make is P. Probability of a miss or failure is X, or 1 minus P. Okay, going on. So here we have just an idea of, suppose a spinner has 3 blue edges and 1 white edge, like this spinner in the picture. Okay, clearly each spin will either get white or blue because the spinner, the top, is going to fall one way or the other. It's got a 3/4 of a chance landing on blue, 1/4 of a chance of landing on white if it's a balanced spinner, and so on. So we build all this stuff, and what happens is we wind up, here's a tree diagram to demonstrate it, but notice, here's what happens. Here we get 1 blue, a white, and a white. Here we get a white, blue, and a white. So that's still only 1 blue. And here we get a white, white, and a blue. So still only 1 blue. Okay, so there are 3 ways that can happen. That's where those numbers come from. So that's where here I'm getting 1 blue. That's where this 3 comes from. And if you remember, that is 3 things taken 1 at a time, which is 3 factorial over 1 factorial, 2 factorial, which just turns out to be 3. So that's where these 3s are coming from, is from that piece of the probability distribution. So we got to go back and look at binomial theorem and binomial probabilities. So that's really where all of this is coming from. Let's go on. So to consider a binomial experiment, we simply have, if x is equal to r, it's the number of items taken r at a time, probability of r times this. And we would do that for all of them. But what happens when if we're trying to find expected or mean outcome of the experiment, is mu. Again, here's that mu again. It's e of x, it's the expected value of x. You simply take the number times the probability, which we've already done. But it gets a little bit more complicated when you're working with parameters n and p, n being the number of experiments, p being probability. You can actually do it on a calculator. What complicates it is if we wind up with an inequality, saying it's got to be at most this. It has to be less than. So that's the key thing here. It must be at most. So sometimes it says at least. You have to actually flip it around and say it's at most. Key is at most r. So if it's asking for what's the probability he's going to make at least 4 free throws, meaning 4 free throws or 5 free throws? Well, we have to go at most. How many would he miss? He'd miss at most 3, so we'd have to switch it around and write it the other way. And we'll show you a little bit here on the calculator right now about how to do that. So let's do an example just to demonstrate. And here's our example. So 70%, 72% of union members are in favor of a change in their conditions of employment. A random sample of 5 members is taken. The probability that 3 members are in favor of change of conditions. What's the probability that 3 of them are in favor of change? Because, well, let's identify our situation here. The number of members being taken is 5, so n is 5. The probability is 0.72. This represents X is distributed by, or according to the parameters of 5 items and a 0.72 accuracy, or 0.72%. This is actually how we're going to find A, because the probability of X is going to equal 3, because it says in the first one, probability of 3 members being in favor. So that's 5 items taken 3 at a time. 0.72 to the third, 1 minus 0.72, which is 0.28, to the second power. And that's what we see here. We multiply all that out to get our actual probability, and it comes out to be 0.293. Okay, now the next piece is where we're going to use the calculator. We could have used the calculator there as well, and I'll show you what that means in a second. Okay, but at least, so we have to switch it around and say at most. At least, what is it saying? At least, second one says, the probability that at least 3 members are in favor. So that means 3 members, 4 members, or 5 members. So we could actually go through and add up. Probability of it being 3, probability of it being 4, plus the probability of it being 5. Right? We could add those up. We could find those 3 probabilities and add them up. Or we can go 1 minus 0, 1, and 2. Because remember, probabilities have to add up to be 1. So we could actually go 1 minus the probability of x equaling 0 plus probability of x equaling 1 plus the probability of x equaling 2 would be the same thing. All right, so continuing, we're going to do this actual part B on the calculator. We'll come back to expected value in a minute. So let's go to the calculator and do this. On the calculator, all right, I'm in a probability simulator here. Okay, so what I want to do on my calculator to get to the probability simulator, I'm going to do distribution. So I go second vars, and it gets me to this distribution. If I go down, I will see there are some binomial distributions on A and B. So a binomial PDF means probability distribution function. I'm going to use a probability distribution function. I'm going to type in what I want. I want a probability distribution function of 5 items, comma, 0.72 is the probability, comma, I only want the number 3, where 3 of them are in favor of a change in working conditions. And I hit enter. Notice it gives me the same answer, 0.2926, that I got when I did it the other way. Or 0.293 is what I got here, what we rounded it to. But what if I wanted to get at least 3? Okay, at least 3. So and what I'm going to have to do on my calculator, I'm going to have to go 1 minus those. Or I could do this all over again, do this all over again with 5 items, 0.72 and 4 times, and then add that to the 0.293 and do it with 5. Or I can go the other way. I can simply go 1 minus. Now I'm going to do a probability distribution, so that's, nope, not y equals. Minus second distributive. And I'm going to go to my binomial cumulative distribution function, which is B. This is a cumulative distribution function. Okay? So CDF, cumulative distribution function. Okay? Hit enter. I'm going to give it the same parameters, 5, comma, 0.72, comma, and it has to be, oh, not 0.72, 0.72. And it has to have if it's greater, if it has to have at least 3, that means the most it can have is 2. So it would have 2. And I put that in and I hit enter. And it's going to go 1 minus 0, 1, and 2. Right, so the probability of making, having 3, 4, or 5 is 0.86%. It did all the work for me. Otherwise, I'd have to take 0.2926 plus the probability of 4 plus the probability of 5, add them together. So it's not a lot of work either way, but it can be done right on a calculator. A probability distribution function. Now, last question here, the expected value. All we have to do for the expected value is take the number of members times the percent, and we should expect to get 0.36. So 5 times 0.72. It's just the number of trials, number of experiments, whatever we're looking for, times the probability. And that's what we get when we talk about it right here. The number times the probability. And we will be working on probability distributions in class.